In this lesson, I'm going to demonstrate how to complete a square in order to solve a quadratic equation. When we complete a square for a quadratic equation, we're finding the x-intercepts. That means that our equation is going to be set equal to 0. So I'm going to write that first. In order to complete the square, the first step is to isolate your x squared and your x variables on one side of the equal sign and put your constant on the other side. So this is step 1. In order to move minus 6 to the other side, I have to add 6 to both sides. When I add 6, the negative 6 cancels out and it moves it to the other side of the equal sign. The second step, so this was step 1. Okay. Step 2 is going to be the leading coefficient of the x squared. We want that to be a 1. And in order to remove that coefficient, you have to divide every term by 2. So we're going to divide this term by 2, this term by 2, and this term by 2. And I'm going to rewrite this. I'll lower this down a little bit. Two divides into 2 once, so we're left with an x squared. I'm going to leave this in fraction form. So I have a minus. I'm going to leave it as a 1 over 2 with an x. And then I'm going to leave a space equals 6 divided by 2, which is 3. The third step is going to find some term that I can put inside of this equation that will make this a perfect square trinomial. And when I add something to the left side of the equation, I also have to add something to the right-hand side of the equation. The way you find that term, I'm going to use this space over here, is you take the coefficient of the x, that's the negative 1/2, and you're going to take half of that number. And once you take half of that number, then you're going to square it. Half of a half is a quarter. We end up with negative 1 over 4. We still need to square this. And when we square it, we get a positive 1 over 16. This is the number I'm now going to move over into our equation because it allows us to complete the square and make a perfect square trinomial. 1 over 16. And we're also going to add it here. So that was step 3, and I'm going to put that in this color here. There's step 3. Step 4 is to rewrite the trinomial as a perfect square binomial. So you take the square root of your first term and put it in, and take the square root of your last term, and we take the sign from the center. And that is our perfect square. That's what we're trying to do, completing the square. We just completed the square. This, however, needs to be combined into one term. So I'm going to use this space right here, and I'm going to add 3 and 1 over 16. In order to add a 3 to the 1 over 16, I have to have the same denominator. So I need a 16 in the denominator. And in order to have a 16 down here, I have to multiply both numerator and denominator by 16. So 3 16s, 32, it's 48, plus 1 over 16 gives me a 49 over 16. What's nice about having a perfect square here is that in order to solve for x, I can now just take the square root of both sides. So step 5 is taking the square root of both sides of the equation. On the right-hand side, on the left-hand side, we end up just with x minus 1/4, because the square root cancels the squaring. And on the right-hand side, we need to remember that when we take a square root, we get two roots. We get a positive root and a negative root. The square root of 49 is 7, and the square root of 16 is 4. And now we want to isolate that x by adding 1/4 to both sides. Sorry, let me do that again. We're going to put this plus and minus sign here. So what this gives us is two separate answers for our x. We have x equal to 1/4 plus 7/4, and we have x equals 1/4 minus 7/4. The top one gives us 8/4. This gives us a 2. And the bottom one gives us a negative 6/4, which is a negative 3/2. So the solution to the original equation that we started with, where we're looking for the y values of 0, what are the x values that make this true? We are given the x values of 2 and of negative 3/2.